Welcome back. In this episode, we'll be looking at how molecular models can help you learn the shapes of molecules, basic conformations, and how cyclohexane cycles through its conformations. For each topic, we'll show that molecular models are a much better representation of molecules than drawings on paper. First, let's start with H2O. You can see from the model that the molecule exists in one plane and it's not linear, it's bent. This is caused by the lone pairs pushing the hydrogens closer together. Now let's look at methane. It's a bit more complicated. From the drawing, we see wedges and dashes along with regular bonds. The wedge means it's coming towards you, while the dash is going away. The model clearly shows this. This bond would be wedged, this one would be dashed. This shape is known as tetrahedral. There are many things that can affect the shape of a molecule. One of these is the number of bonds. For example, ethane has a single bond, while ethene has a double bond. You can see that ethane has bonds in all 3 dimensions, while ethene is only in 2 dimensions. For our next topic, we'll be looking at how models show which conformations are more stable. For ethane, in its eclipse conformation, it's easy to see how close these hydrogens are together, meaning it's less stable than its staggered conformation, where they're farther apart. It's even easier to see when adding 2 methyl groups, forming butane. These two are very close together, so this conformation, known as syn-eclipse, isn't stable. This molecule is most stable in its anti-staggered form, where the methyl groups are farthest apart. In our final segment, we'll talk about how molecular models show the many conformations of cyclohexane. We'll start with its most stable conformation, the chair. With the model, it's easy to see the axial hydrogens are pointing straight up and straight down, while the equatorial hydrogens are pointing outwards. I'll now switch the axial hydrogens for green atoms, making them easier to identify. From the chair, we'll go to the half chair, then to the boat, twisted boat, and finally to the reverse chair. It's easy to see that the green atoms are now equatorial and the white ones are now axial, meaning they switch place. This concludes our episode for today, showing you how molecular models can help you learn the shapes of molecules involved in organic chemistry.